The universe began billions of years ago. We know this. Massive stars lived and died. Black holes formed in the aftermath. They grew. They collided. This is what we understood for centuries. This is what every textbook told us. But there was a problem. The math could not explain what we were actually finding. For 70 years, astronomers wrestled with a terrible contradiction. The numbers did not work. The equations screamed. The physics itself seemed to be lying to us. Then, in 2023, everything changed. Scientists detected something impossible. Two supermassive black holes had collided. Not ordinary black holes, not the kind we expected to see. These were titans, monsters so massive that their very existence violated everything our theories predicted. 225 times the mass of our Sun, compressed into a single, unified point of infinite density. And this was not an isolated event. Weeks later, another collision. Months later, another. The detections kept coming, each one more massive than the last, each one more impossible than the previous. The scientific community faced a crisis. Not a crisis of data, but a crisis of understanding. The universe was revealing secrets we were not prepared to comprehend. And that revelation was merely the beginning. What happened before these collisions? What cosmic machinery brings titans together across the void? What forces operate in the darkness, guiding these monsters toward their inevitable merger? The answers shatter everything we believed about gravity, about space, about time itself. They force us to reconsider the very architecture of reality. These events are not rare anomalies. They are not statistical outliers hiding in the noise. They are common. They are systematic. They are telling us that our models of black hole formation were fundamentally incomplete. For decades, we believed we understood how black holes grew. We thought we had mapped the pathways. We constructed elegant theories that seemed to work on paper. But nature laughed at our theories. Nature laughed and showed us something we never expected to find. Consider what we thought we knew. A black hole forms when a massive star dies. The star collapses. It becomes so dense that not even light can escape. We call this the event horizon, the point of no return. For generations, astronomers believed that black holes grew slowly, steadily, predictably. They consumed gas and dust from their surroundings. They merged occasionally with other black holes. But these mergers were rare, extraordinarily rare. The resulting black holes should never exceed certain mass limits. This was not speculation. This was mathematics. This was Einstein's theory working exactly as predicted. Except it was not working. The universe was producing black holes that should not exist. Supermassive black holes. Ultramassive black holes. Monsters that violated the speed limits of cosmic growth. How could they exist if the theories were correct? They could not. This meant the theories were wrong, or incomplete, or both. Then came the breakthrough. Not in theory, in observation. Scientists built gravitational wave detectors, LIGO, Virgo, Cagra, machines so sensitive they could feel the vibrations of spacetime itself. Imagine constructing instruments capable of detecting ripples in reality, disturbances so subtle that they compress and expand an entire laser beam by a fraction of an atom's width. This is not metaphor. This is literal fact. These machines became the ears of the cosmos, and they began to hear something extraordinary. When massive objects accelerate through space, when they collide or orbit each other, they send ripples through the fabric of reality itself. These ripples carry information. They carry evidence of events that happened billions of years ago. They carry secrets that light could never tell us. In November 2023, one of these detectors registered something unprecedented. A signal, a clear, unmistakable signal of two supermassive black holes merging. The gravitational waves lasted for fractions of a second, but in those fractions of a second, they revealed an event of staggering proportions. The numbers were incomprehensible. The merging black holes had a combined mass of approximately 225 solar masses, more than 200 times heavier than our Sun, compressed into a region of space smaller than our solar system. The energy released during this event defied rational description. For a fraction of a second, this merger released more energy than all the stars in the observable universe generate in an entire year. Impossible, but measurable, documented, real. This was not the only detection. Others followed. In October 2024, another merger was observed. In November 2024, yet another. Each one massive, each one impossible, each one confirming that something fundamental was wrong with our understanding of the cosmos. The implications were staggering. If these detections were real, and they were undeniably real, then the universe operated according to rules we did not understand. Black holes could grow to impossibly massive scales. Merger events could happen more frequently than we predicted. The cosmos was far more violent, far more dynamic, far more extreme than our textbooks suggested. But the mystery ran deeper still. How did these black holes become so massive? Where did they come from? What process could create monsters of such scale? The old answers did not work. The standard models of stellar evolution could not produce black holes this heavy. The timescales were wrong. The physics did not permit it. Something else was happening. Something we had not yet discovered. Something that operated in the cosmic darkness, beyond the reach of our telescopes, hidden in the secret mechanisms that shape the universe itself. This is where our journey begins, not with the collision itself, but with everything that came before, the events that led to the merger, the cosmic machinery that brought these titans together, the laws of physics that govern their dance, the mysteries that their collision illuminated. We stand at the threshold of a new understanding of reality. On the other side of that threshold lies a universe far stranger, far more violent, and far more wondrous than we ever imagined. Before we witness the collision, before we see the moment when two horizons of infinite density became one, we must first understand the journey that preceded it. We must trace the path of these monsters through cosmic time. We must discover what forces guided them toward their inevitable meeting. We must comprehend the machinery that operates in the depths of space, reshaping reality itself with every passing moment. This solved one problem, but it created an even bigger mystery. What happened before the merger? What brought these titans together? And that question leads us directly into the darkness. Two galaxies exist at opposite ends of a cosmic void. They are separated by millions of light years. Each contains a supermassive black hole at its center. These black holes are not aware of each other. They do not know the other exists. But gravity does not require knowledge. Gravity does not require consciousness. It only requires mass. And mass bends the fabric of spacetime relentlessly, inevitably, without mercy. The two galaxies drift through space. They are not stationary. Nothing in the universe is stationary. Everything moves. Everything falls. The universe is not a still photograph. It is a violent film, playing in accelerated time across billions of years. And sometimes, by cosmic chance, two galaxies find themselves on a collision course. Their paths intersect, not in an instant, but over millions of years they draw closer, imperceptibly closer, millisecond by millisecond, generation by generation. The stars inside each galaxy have no idea what is happening. Life on planets orbiting those stars knows nothing of the approaching catastrophe. The process is silent. The process is patient. The process is inevitable. Imagine two ice skaters approaching each other across a frozen pond. They are not moving in straight lines. They are orbiting each other, circling, getting progressively closer with each rotation. This is friction. This is dynamic friction. The gravitational pull between the two galaxies creates a drag effect. It is like two swimmers in a pool creating currents that pull each other closer. Except the scale is unimaginable. The galaxies contain hundreds of billions of stars. Each star is a massive fusion reactor. The energy involved is beyond human comprehension. Yet the process is still governed by the same fundamental laws. Newton's laws of motion, Einstein's theory of gravity. The mathematics is brutal but beautiful. The equations reveal a universe that operates with perfect, merciless precision. As the galaxies approach, their stars begin to interact gravitationally. Some stars are ejected from their original orbits. Some are pulled into new trajectories. The structure of each galaxy begins to distort. The spiral arms that once swept elegantly through space become warped and twisted. It is like watching two whirlpools merge. The edges lose their definition. The boundaries blur. The once pristine spiral galaxies become grotesque, stretched forms. Tidal forces rip at the fabric of each system. Stars that spent billions of years in stable orbits suddenly find themselves on the paths toward destruction. Some will collide with other stars. Some will be catapulted into the intergalactic void, never to return. The galaxy is being torn apart, not by any external force, but by its own gravitational interaction with its approaching neighbor. The collision has begun long before the galaxies actually touch. At the very center of each galaxy, something far more extreme is occurring. The supermassive black holes. These objects are the gravitational anchors of their galaxies. They sit at the centers, watching, waiting. They do not move toward each other initially. The approach is slow, glacial, but inexorable. As the galaxies draw closer, the black holes begin to sense each other's presence. The gravitational field of one distorts the spacetime around the other. It is like standing next to a massive weight. You feel the pull. You feel the distortion of space around you. The black holes experience this constantly. They feel each other across the void. The distortion increases. The pull becomes stronger. And then something critical happens. The black holes enter a new phase of interaction. The galaxies have come close enough that their central regions overlap. The stars from one galaxy invade the space around the other galaxy's black hole. This is where dynamic friction becomes decisive. These stars do not pass through the black hole. They orbit around it, but in doing so, they lose energy. This is the key principle. Whenever two massive objects interact gravitationally, they lose energy to gravitational radiation. They lose energy to tidal heating. They lose energy through 1,000 subtle mechanisms that thermodynamics demands. The stars slow down. They cannot maintain their original orbits. They spiral inward. Some are captured by the black hole. Others are ejected at high velocity. This process is violent. This process is chaotic. But the net result is always the same. the two black holes lose orbital energy. They get closer. They sink deeper into the merged gravitational potential well. The two black holes are now in a binary system. They orbit each other. Not like planets around a star, but like two massive objects locked in a dance from which there is no escape. The orbital period is measured in millions of years. They circle each other with inexorable regularity. With each orbit, they lose energy. With each orbit, they spiral closer. The process accelerates, slowly at first, then faster and faster. The separation between them decreases. The gravitational pull intensifies. The tidal forces become extreme. Any matter between them is shredded. Any stars unfortunate enough to be caught in their gravitational embrace are torn apart. The region around these two black holes becomes a hell realm, a place where the laws of physics are pushed to their absolute limits. But something profound is happening that we cannot yet see with our eyes. We cannot detect it with ordinary telescopes. We cannot photograph it with cameras, yet it is real. It is happening right now. The black holes are generating gravitational waves. They are rippling space-time itself. Einstein predicted this over a century ago. Gravity, he said, was not a force. It was the curvature of space-time. When massive objects accelerate, they send ripples through this curvature. These ripples propagate outward at the speed of light. They carry energy. They carry information. They carry evidence of events happening in the cosmic depths. As the two black holes circle each other, they emit these waves constantly, waves upon waves, an increasing frequency of vibrations. The universe itself is beginning to sing. The song is faint at first, barely perceptible, but it is there. And as the black holes spiral closer, the song grows louder, stronger, more insistent. The vibrations of space-time increase in amplitude. The energy loss accelerates. The process enters a new phase. The two black holes are no longer slowly approaching. They are beginning their final descent. The inspiral has begun. This is where the story truly becomes strange. The inspiral phase is unlike anything in human experience. Two black holes locked in an eternal orbit, getting closer, always closer. The separation that once spanned millions of kilometers shrinks relentlessly. Thousands of kilometers, hundreds of kilometers, tens of kilometers. The speed of their orbital motion increases exponentially. What began as a leisurely dance becomes a frantic waltz, then a violent thrashing. The laws of space-time themselves begin to contort under the strain. Near the event horizons, gravity reaches intensities that defy description. The tidal forces are so extreme that atoms would be torn apart. Molecules would be ripped into constituent particles. Even light itself bends and warps as it passes through this infernal region. There is no place in the observable universe more extreme than the region separating two orbiting black holes in their final inspiral. The gravitational waves intensify dramatically during this phase. They are no longer a whisper. They are a scream, a constant, escalating scream that ripples through the fabric of reality. The frequency increases, the amplitude grows, the energy flux becomes staggering. The two black holes lose orbital energy at an accelerating rate. Where previously they spiraled inward over millions of years, now the process accelerates. Decades become years, years become months, months become days. The orbital period shrinks from hours to minutes to seconds. The mathematics of general relativity becomes absolutely critical. Classical Newtonian physics is useless here. Only Einstein's equations capture what is actually happening, and they reveal something profound. The process becomes self-accelerating. The faster the black holes orbit, the more gravitational waves they emit. The more waves they emit, the more energy they lose. The more energy they lose, the closer they get. The closer they get, the faster they orbit. It is a positive feedback loop, a spiral toward catastrophe that cannot be stopped, that cannot be slowed, that cannot be deflected. The universe is a machine designed specifically to accelerate this process toward its inevitable conclusion. Consider the space-time surrounding these two titans. It is not smooth. It is not serene. It is violently distorted. Imagine taking a rubber sheet and placing two bowling balls on it. The sheet warps around them. It sags. It curves. The curvature is dramatic. Now imagine those bowling balls getting closer, closer. The curvature intensifies. The rubber sheet becomes increasingly warped. The space between them becomes a funnel, a gravitational vortex pulling everything inward. Any matter that enters this region is doomed. It will be torn apart. It will be incinerated. It will be consumed. The black holes themselves create what physicists call a binary black hole potential well. It is a trap from which nothing can escape. Stars that venture too close are captured. Gas clouds are shredded. The entire galactic environment around these two black holes becomes a maelstrom of destruction. The gravitational waves propagate outward at the speed of light. They carry away angular momentum. This is crucial. As the black holes orbit each other, they possess angular momentum. It is momentum of rotation. This momentum must go somewhere. It cannot simply vanish. It is carried away by gravitational waves. The waves ripple through space-time. They travel outward in all directions. They pass through galaxies. They pass through empty space. They travel for billions of years. Some eventually reach Earth. They reach our gravitational wave detectors. The waves carry a signature of the source. They encode information about the masses of the black holes, about their spins, about the details of their merger. Scientists can read this information. They can reconstruct what happened billions of years in the past. They can hear the cosmic song of two titans dancing their final dance. The spin of each black hole becomes critical during inspiral. Black holes are not static objects. They rotate. Some rotate slowly. Some rotate near the speed of light. The direction of rotation matters enormously. If one black hole rotates clockwise and the other counterclockwise, the angular momentum configuration is chaotic. The gravitational waves are emitted asymmetrically. The resulting merger is more violent. The recoil is more extreme. Recent detections have revealed something shocking. Some merging black holes have spins that are misaligned. They rotate in opposite directions. They rotate in planes that are nearly perpendicular to each other. This is bizarre. This should not happen frequently. Yet we are observing it. This is another indicator that our models are incomplete. The binary black holes are more complex than we understood. They spin, they wobble, they precess. The geometry of their orbits is three-dimensional and constantly evolving. The accretion disks surrounding these black holes play a dramatic role during inspiral. As the black holes approach each other, material in the surrounding environment spirals into them. Gas and dust form accretion disks. These disks are heated to extreme temperatures. Friction between particles generates heat. Magnetic fields in the disk amplify. The material becomes luminous. Brilliant. The binary black hole system becomes one of the brightest objects in the universe. X-rays pour out. Ultraviolet radiation floods the region. Jets of material shoot outward at nearly the speed of light. To an external observer, this system would appear as a blazing beacon, a cosmic lighthouse, a sign that something extraordinary is happening at the galaxy's core. This is not subtle. This is not hidden. This is violent, energetic, and unmistakable. The tidal forces continue to intensify. Anything near these black holes experiences extreme acceleration. A person standing at one point on the surface would be stretched like taffy. One part of their body would experience dramatically stronger gravity than another part. They would be torn apart, literally, vertically. This is called spaghettification. The tidal force gradient becomes so extreme that it separates atoms. It rips nuclei apart. The only things that can survive in this region are the most robust structures, perhaps neutron star material, perhaps degenerate matter, but organic matter? Life as we understand it? Absolutely impossible. And yet, this is where the universe operates in its most extreme mode. This is where physics reaches its absolute limits. This is where reality itself begins to break down under the strain of such intense gravity. The binary black hole system becomes a testing ground for theoretical physics. Every prediction of general relativity is pushed to its absolute limit. Space-time curvature reaches values that are ordinarily considered impossible. The Riemann curvature tensor, the mathematical object that describes how space-time is bent, reaches values so extreme that they approach the Planck scale. The Planck scale is the boundary between general relativity and quantum gravity. It is the scale at which quantum effects of gravity become important. At smaller scales, the laws of physics that we know and love break down. New physics emerges, physics that we do not yet understand. The binary black hole merger is pushing us toward that boundary. It is showing us the limits of Einstein's theory. It is hinting at the quantum nature of gravity. And most importantly, it is preparing us for what comes next. The final plunge, the moment when two black holes stop orbiting each other and fall toward each other at ever-increasing speed. The moment when space-time itself reaches its breaking point. The region around merging black holes is not quiet. It is not dark. It is screaming with radiation. The universe is cooking. The laws of thermodynamics are working overtime. Every kilowatt of gravitational binding energy that is released heats the surrounding material to unimaginable temperatures. This is not a gradual process. This is not a gentle warming. This is violent. This is catastrophic. The accretion disks surrounding the black holes reach temperatures of millions of degrees. Plasma forms. Subatomic particles collide at relativistic speeds. The energy density becomes comparable to the interior of a star, except stars burn for billions of years. These disks exist in states of temporary stability. They are inherently unstable. They are constantly on the verge of collapse or ejection. They are explosive environments waiting for the trigger. And the trigger is coming. The approach of merger day. The electromagnetic radiation cascading from these systems is staggering. X-rays flood outward. Gamma rays pierce the darkness. Ultraviolet radiation bathes the surrounding space. The system becomes visible across the entire electromagnetic spectrum. Telescopes designed to detect radio waves can see it. Telescopes sensitive to infrared can see it. Optical telescopes can see it. X-ray observatories capture images of the mayhem. The binary black hole system is not hidden. It is broadcasting its existence across the cosmos. It is screaming to the universe. We are here. We are dying. We are magnificent. Astronomers on Earth, when they observe such systems, are seeing light that has traveled for billions of years. They are seeing the past. They are witnessing events that happened eons ago. And what they see is chaos. Pure, unadulterated chaos. The magnetic fields in these regions reach intensities that would drive any magnetic field on Earth into insignificance. Earth's magnetic field, which protects us from solar wind, is measured in microtesla. The magnetic fields around merging black holes reach values measured in terateslae. A terateslae is 1 trillion Tesla. The difference is incomprehensible. These magnetic fields are so intense that they can accelerate particles to relativistic speeds. They can focus radiation into beams. They can create jets of matter that shoot outward at 1,000 kilometers per second. These jets are visible across intergalactic distances. Astronomers see them regularly. They call them relativistic jets. They are one of the most energetic phenomena in the universe, and they originate from the region around merging black holes. The accretion rate increases exponentially as the black holes approach merger. This is a key fact. Early in the inspiral phase, when the black holes are still relatively far apart, the accretion rate is merely extreme. Millions of Earth masses of material spiraling into the black holes per second. Impossible. But as the black holes get closer, the tidal forces intensify. More material gets disrupted. More material gets funneled into the accretion disks. The rates skyrocket. Tens of millions of Earth masses per second. Hundreds of millions. 1 billion Earth masses per second. The material cannot come fast enough. The universe is pulling matter into these black holes at speeds that seem to violate common sense. Yet the mathematics of gravity allows it. The mathematics insists upon it. The process becomes self-reinforcing. The brighter the system becomes, the more radiation it emits. The more radiation it emits, the more energy is available to accelerate more material. The process spirals toward a crescendo. Gravitational lensing becomes a spectacular phenomenon in these regions. Gravity bends light. Einstein proved this. The more extreme the gravity, the more dramatic the bending. In a system of merging black holes, gravity is extreme beyond measure. Light traveling near the black holes follows curved paths. It bends, it warps. It can be magnified dramatically. An object behind the black hole system, from the perspective of a distant observer, will appear distorted. It might appear multiple times. It might appear stretched into arcs. It might appear brightened or darkened depending on the precise geometry. The binary black hole system acts as a cosmic lens. It magnifies the light of objects billions of light years away. It distorts them. It transforms them. The region becomes a laboratory for testing gravitational physics in its most extreme regime. The disks surrounding the black holes become violent maelstroms as merger approaches. They are not stable structures. They are constantly being torn apart by tidal forces. Material from one disk spirals into one black hole. Material from another disk spirals into the other. But there is a third component. Material caught between the two black holes. This material experiences maximum tidal stress. The black hole on one side pulls with titanic force. The black hole on the other side pulls with equal ferocity. The material is stretched. It is shredded. It is incinerated. The temperature spikes to billions of degrees. Nuclear fusion ignites. Alpha particles collide at relativistic speeds. Neutrons and protons are separated. The material undergoes nuclear disintegration. This is the most extreme nuclear oven in the universe. The heat production is staggering. The radiation output rivals that of billions of suns. the binary black hole system enters what physicists call the quasi-circular phase. The orbits become nearly circular, nearly perfect circles. The eccentricity decreases towards zero. This is counterintuitive. One might expect the orbits to become more chaotic as the black holes approach. Instead, they become more orderly, more regular. This is due to the properties of gravitational radiation. Eccentric orbits lose energy preferentially through the periapsis passages, the moments of closest approach. Circular orbits lose energy uniformly throughout each orbit. Eventually, through this process, eccentric orbits become circular. This is gravitational wave circularization. It is a mathematical consequence of Einstein's equations, and it makes the final merger even more violent. The black holes approach with predictable regular rhythm, like a cosmic metronome. Tick, tick, tick. Each tick brings them closer. Each tick increases the frequency. Each tick brings the system closer to catastrophe. The timescale of the merger becomes compressed. As the final moments approach, processes that took millions of years suddenly occur in seconds. The orbital period shrinks from hours to minutes to seconds. The frequency of gravitational waves increases from hertz to kilohertz to hundreds of kilohertz. The amplitude of spacetime distortion reaches maximum values. The system becomes a furnace of incomprehensible intensity. Everything in the surrounding region is subjected to extreme forces. The radiation output reaches levels that are truly unimaginable. If a human observer could survive in this environment, they could not. They would witness a transformation of spacetime itself. Reality would appear to melt. The boundaries between the black holes would become indistinct. The horizons of events would blur together. The mathematics predicts that the separation between the black holes shrinks to zero. The orbits become impossible. The physics demands a new state, a transition, a final merger. And that transition is what we must now explore. The moment when two titans become one. The moment when spacetime reaches its absolute limit. The moment when the universe enters its most extreme state. The moment arrives, the moment before the final plunge. The binary black hole system has reached a critical threshold. The black holes are now so close that the acceleration is extreme. The tidal forces are at their maximum. The space-time curvature approaches values that physics itself struggles to describe. This is the moment when the universe transitions from the extraordinary to the impossible. This is the threshold moment, the instant before everything changes. And in this moment, phenomena of staggering intensity flood the surrounding space. The entire region becomes a cosmic accelerator, a machine designed by the laws of physics to generate catastrophic events. The accretion of material reaches its absolute peak. What began as a steady stream becomes a torrent. What was a torrent becomes a flood. What becomes a flood becomes absolute chaos. The black holes are pulling in billions of Earth masses of material per second, every second. This is not exaggeration. This is the mathematical consequence of tidal disruption. Stars that venture too close are torn apart. Their material spirals inward. Gas clouds collapse under gravity. Their substance is compressed and heated. The accretion disks become impossibly dense, impossibly hot. The material orbits closer and closer to the event horizons. The final moments approach. The velocity of infalling material reaches relativistic speeds, 1/10 the speed of light, 1/3 the speed of light, half the speed of light. The material is moving so fast that relativistic effects become dominant. Time dilation becomes extreme. Mass increases dramatically. Kinetic energy becomes comparable to rest mass energy. The distinction between matter and energy blurs. The distinction between energy and radiation blurs. The system enters a regime where Einstein's equations are absolutely critical. Newton's laws are useless. Classical physics is a relic of a simpler time. Only quantum relativistic descriptions capture the truth of what is occurring. The radiation output reaches levels that defy human comprehension. The binary black hole system becomes one of the brightest objects in the observable universe, not just in X-rays, across the entire electromagnetic spectrum. Radio telescopes detect intense emissions. Millimeter wave telescopes see brilliant signals. Infrared detectors are overwhelmed by heat radiation. Optical telescopes photograph brilliant light. Ultraviolet observatories record extreme emissions. X-ray telescopes capture images of catastrophic violence. Gamma-ray detectors register intense bursts. The entire electromagnetic spectrum is ablaze. The system is broadcasting its existence across billions of light years. To a distant observer, a binary black hole merger in its final moments appears as a beacon, a cosmic lighthouse, a supernova that lasts for years. The power output is incomprehensible. Terawatts, petawatts, exawatts, numbers so large that human language fails to capture them meaningfully. Compare this to the total power output of all the stars in the observable universe. That output, combined, is less than the radiation pouring from a merging binary black hole system. The jets become increasingly intense. The magnetic fields have been wound up and compressed by the rotation. They reach strengths that drive particles to speeds approaching light velocity. The jets shoot outward from the poles of the black holes. They propagate outward at relativistic speeds. They carry enormous quantities of energy. The jets can extend for millions of light years. They create structures visible on the largest astronomical scales. Radio telescopes, which detect synchrotron radiation from jets, see these structures regularly, enormous jets emanating from distant galaxies. These jets are often powered by merging black holes. They are created during the inspiral phase. They intensify toward the merger, and then they abruptly cease when the merger completes. The jets disappear. They vanish. The reason for their disappearance is profound. The merger process itself disrupts the accretion. The magnetic field configuration changes. The geometry of the system transforms. The jets cannot be sustained in the new configuration. They shut off. The universe transitions into a new phase. Gravitational lensing effects become spectacular. The intense gravity surrounding the merging black holes acts as a cosmic magnifying glass. Objects behind the system, billions of light years away, appear distorted. They appear magnified. They appear multiple times. The images can be incredibly bright due to the lensing effect. Distant quasars, themselves brilliant objects, appear even more brilliant when lensed by a binary black hole system. Distant galaxies appear stretched into arcs. The boundary between gravitational lensing and gravitational wave interactions becomes blurred. The space-time distortion is so extreme that both effects operate simultaneously. The light is lensed. The space-time is rippled. The two effects interfere with each other. The resulting patterns are incredibly complex. They contain encoded information about the black hole masses, spins, and orbital geometry. Future telescopes, more sensitive than today's instruments, will exploit these patterns. They will reconstruct the details of mergers in unprecedented precision. The temperature in the inner accretion disk reaches billions of degrees. Billions. This is not metaphorical. This is the actual temperature. The heat is so intense that particle-antiparticle pair production occurs. Photons convert into matter-antimatter pairs. The pairs annihilate and produce more photons. The system enters a regime of extreme plasma physics. The particles move at relativistic speeds. The electromagnetic forces are as important as gravity. The system becomes a laboratory for studying the most extreme physics imaginable. The conditions approach those present in the first moments after the Big Bang. The universe is recreating, in this tiny region, the conditions that existed billions of years ago when the entire cosmos was compressed into an infinitesimal point. This binary black hole system is a time machine. It is showing us physics that we could never study in laboratories. It is showing us the fundamental nature of reality, pushed to its absolute limits. The luminosity increases exponentially in the final days before merger. Where the system was brilliant yesterday, it becomes impossibly bright today. Where it is impossibly bright today, it will become something beyond description tomorrow. The increase in luminosity is not gradual, it accelerates. The second derivative of luminosity with respect to time is positive and increasing. This is mathematical language for describing something that is accelerating faster and faster. The system is reaching a crescendo. The music is building toward a climax. Every moment, the intensity increases. Every moment, the radiation output climbs. Every moment, the space-time distortion becomes more extreme. The end is approaching. The final merger is imminent. The two black holes are so close that the individual orbits can no longer be distinguished from the outside. The system appears as a single, brilliant object undergoing violent oscillations. The oscillations are getting faster. The amplitude is increasing. The system is resonating. It is vibrating. It is singing its final song before the two voices merge into one. And in this moment of supreme intensity, something remarkable is happening that we cannot see with any traditional telescope. Something invisible. Something that requires specialized instruments to detect. The gravitational waves are reaching their maximum amplitude. The frequency is reaching its maximum. The two black holes are orbiting at thousands of kilometers per second. The separation between them is less than 10 times the diameter of the event horizons. The tidal forces are so extreme that they are literally tearing apart the fabric of space-time. And the space-time ripples, the gravitational waves, are growing louder and louder. They are becoming a scream, a cosmic scream, a sound that ripples through the fabric of reality itself. And this is the sound that our detectors on Earth will soon capture. This is the signal that will reveal the secrets of the merger. But to understand how we hear this cosmic scream, we must first understand the fundamental nature of gravitational waves themselves. We must understand what Einstein predicted. We must understand how these ripples carry information across the cosmos. Einstein made a prediction in 1916. Gravity is not a force. This was his revolution. Gravity is the curvature of space-time. Massive objects bend space-time around them. When massive objects accelerate, they ripple space-time. These ripples propagate outward at the speed of light. Einstein called them gravitational waves, but Einstein was unsure. He doubted his own prediction. He wrote to a colleague, "I do not believe they exist." For decades, physicists debated whether gravitational waves were real or mathematical artifacts, theoretical constructs without physical manifestation. Then, in 2015, the debate ended. LIGO detected the first gravitational wave. Two black holes had merged 1 billion light-years away. The ripples traveled through space for 1 billion years. They reached Earth. A machine on Earth felt them. The machine trembled. The impossible became inevitable. The mathematical prediction became physical reality. And with that detection, the nature of astronomy changed forever. Understand what this means. For millennia, humanity observed the universe through light, visible light, infrared light, ultraviolet light, radio waves, X-rays, gamma rays, all forms of light. Light is electromagnetic radiation. It travels at light speed. It carries information about distant objects. But light can be blocked. Dust clouds obscure light. Gas clouds absorb light. Stellar winds scatter light. The universe is opaque to much of the light traveling through it. Telescopes see only a fraction of cosmic phenomena. Entire regions of the universe are hidden. The centers of galaxies, the cores of black hole mergers, the innermost regions of stellar explosions. These regions are shrouded in darkness. Light cannot reach us, but gravitational waves can. Gravitational waves pass through dust. They pass through gas. They pass through any material in their path. Nothing stops them. Nothing blocks them. They are the universe's way of speaking to us through channels that light cannot reach. They carry information about events that are completely invisible to traditional astronomy. The LIGO detector is a machine of impossible precision. Laser Interferometer Gravitational Wave Observatory. 2 arms extending 4 kilometers in length, perpendicular to each other. A laser beam travels down one arm and reflects off a mirror at the end. The beam travels down the other arm and reflects off another mirror. The beams return and interfere with each other. Usually, they interfere perfectly. The pattern is stable, but when a gravitational wave passes through the detector, something extraordinary happens. The wave stretches space-time. It makes one arm slightly longer and the other slightly shorter. The change is minuscule, incomprehensibly small. The length change is smaller than the diameter of a proton. The laser beams, traveling through this distorted space-time, pick up the distortion. The interference pattern changes. The signal is detected. This is not exaggeration of the precision. This is literal fact. LIGO is the most sensitive instrument ever constructed by humanity. It can detect changes in distance 1 million times smaller than the width of a human hair. Virgo is another detector. In Italy, 3 kilometers of laser arms. The 3 major detectors, LIGO in Washington, LIGO in Louisiana, and Virgo in Italy, work in concert. They form a network. When a gravitational wave passes through the network, each detector feels it at slightly different times. The time delays encode information about the direction of the wave source. Where did the wave come from? Multiple detectors tell us. Kagra in Japan adds more precision. 4 detectors across the globe. A network sensitive to gravitational waves from any direction. The detectors are constantly monitoring, listening, waiting for the cosmic song to reach Earth. And regularly, the song arrives. Black hole mergers announce themselves. Neutron-star collisions broadcast their existence. The gravitational wave detectors hear the news from across the universe. When a gravitational wave passes through LIGO, the signal is unmistakable. It has a characteristic shape. Scientists call it the chirp. The frequency increases with time. Think of it as a musical note whose pitch increases, higher and higher and higher. The volume, the amplitude, also increases. The chirp starts faintly, then builds, the frequency climbs, the amplitude grows, and then it stops. Suddenly, the signal vanishes. The merger is complete. The two black holes have become one. The ripples cease. Silence returns. But in those seconds, sometimes fractions of a second, an enormous amount of information is encoded in the chirp. The rate of frequency increase tells us the masses of the black holes. The final frequency tells us where the merger occurred and how the objects were oriented. The amplitude tells us the distance to the source. The total duration tells us about the orbital dynamics. Every detail of the signal reveals cosmic secrets. Scientists analyze the chirp. They extract the information. They reconstruct what happened billions of light years away, billions of years ago. The first detection in 2015 revealed a merger of two black holes, each about 30 solar masses. The resulting black hole was about 60 solar masses. 5 solar masses of energy was converted to gravitational radiation. E equals mc squared. 5 solar masses times the speed of light squared. The energy was astronomical. In fractions of a second, more energy was released than all the stars in the observable universe produce in an entire year. This energy radiated outward as gravitational waves. The waves carried the energy away. The waves carried away angular momentum. The waves carried information across the cosmos. When LIGO detected these waves, scientists could reconstruct the event in exquisite detail. They knew the masses. They knew the spins. They knew the orbital dynamics. They knew that Einstein's prediction, made a century earlier, was absolutely correct. General relativity passed the test. Gravity is truly space-time curvature. Accelerating masses ripple space-time. These ripples propagate at light speed, and we can detect them. Since that first detection, hundreds of mergers have been observed. Each event tells a story. Each event provides data. Each event refines our understanding of the universe. Binary black hole mergers are common, more common than initially predicted. Neutron star mergers are observed. These produce different signals, different frequencies, different durations. But all gravitational wave signals carry profound information. The signals reveal the masses of merging objects. The signals reveal the spins. The signals reveal whether the objects are black holes or neutron stars. The signals reveal the geometry of the merger, and when multiple signals are combined, patterns emerge. Statistical patterns, population patterns, distribution patterns. From individual events, we build a picture of the entire population of merging objects in the universe. We understand how common they are, where they occur, how they form. Gravitational waves are revolutionizing astronomy. They are opening a new window on the cosmos, a window that is fundamentally different from traditional light-based astronomy. The most recent detections have revealed something shocking. Black holes more massive than we believed possible. The first surprise came in 2015 with those 30 solar mass objects. But since then, larger and larger mergers have been observed. 50 solar masses, 70 solar masses, 100 solar masses. These masses were not predicted by standard stellar evolution models. They should not exist, and yet they do. The gravitational wave detectors have documented their existence. They have provided irrefutable evidence. The universe is producing black holes of unexpected masses through processes we do not yet fully understand. This is the revolution. Not just the detection of gravitational waves, though that was profound. But the revelation that the universe operates according to rules we did not anticipate. The rules are different from what we taught in textbooks. The universe is stranger, more extreme, more violent than we imagined, and gravitational waves are revealing these truths. They are showing us a universe we could never see through light alone. The cosmic whisper has become a roar, and the roar is telling us that something fundamental is wrong with our models. Something fundamental is wrong with our understanding, and that realization leads directly to our next truth. The black holes that we detect merging today are not first-generation objects. This is the revelation. They are not the direct offspring of the first massive stars. They are veterans, survivors of previous mergers, second generation, third generation, perhaps even older. The math makes this clear. The masses we observe are too large for standard stellar evolution. A single massive star, no matter how enormous, cannot produce a black hole exceeding about 20 solar masses through normal processes. The mass loss during stellar evolution prevents it. The physics does not allow it. And yet we observe black holes of 50, 70, 100 solar masses. The only explanation is merger, repeated merger, cascading collisions. The binary black holes detected today are the products of ancient collisions. They are cosmic survivors. They have collided once, perhaps multiple times, and now they are colliding again. Imagine a black hole born from the collapse of a massive star. It has 10 solar masses. Brilliant, powerful, but ordinary by cosmic standards. This black hole drifts through space. It enters a stellar cluster, a region of space containing millions of stars, perhaps thousands of other black holes. The density is extreme. The gravitational interactions are constant. Stars orbit black holes. Black holes interact with other black holes. The dynamics are chaotic, unpredictable, and occasionally catastrophic. Two black holes approach each other. Gravitational interaction brings them into a binary orbit. They spiral together. They merge. A new black hole is created. It has 15 solar masses, 10 plus 10 minus some energy radiated as gravitational waves. The new black hole is heavier, stronger. It remains in the cluster. It continues to interact with other objects, and eventually it encounters another black hole, another merger. The mass grows. 20 solar masses, 25, 30. The process repeats. It is a cosmic ladder. Each collision adds mass. Each merger creates a more massive object, cascading collisions, a hierarchical buildup. This process occurs in the densest environments in the universe: globular clusters, nuclear star clusters, the centers of galaxies, regions where thousands or millions of stellar mass black holes coexist in relatively small volumes. The collision rate is high. The merger timescale is short. Compared to the age of the universe, these collisions happen rapidly. A black hole in such an environment might undergo multiple mergers in its lifetime. The mass increases. The final black hole is significantly heavier than any first-generation object. This is how we produce the massive black holes we observe today, not through the collapse of individual stars, but through the accumulation of merger products. The universe is building monsters through systematic, repeated violence. The recent gravitational wave detections reveal signatures of this process. The black holes being observed have masses that clearly indicate merger history. A black hole of 75 solar masses almost certainly formed through prior collisions. The gravitational wave signals sometimes show evidence of multiple merger generations. The orbital dynamics encode this history. The spins encode this history. A black hole that has undergone previous mergers has a characteristic spin distribution. It rotates in specific ways. It has specific angular momentum properties. Scientists analyzing the gravitational wave data can sometimes identify these signatures. They can see that a merging black hole was itself a product of previous mergers. The universe is writing its history in gravitational waves. We are learning to read the story. The most massive black holes detected show clear signs of complex merger histories. The GW231123 event involved black holes with approximately 110 and 115 solar masses. These masses are impossible for first-generation objects. They must be second- or third-generation products. The merger produced a black hole of approximately 225 solar masses, a monster created from monsters. The gravitational wave signal encoded this entire history. Scientists extracted the information. They confirmed the interpretation. These were not the first generation. These were veterans of previous cosmic violence, and their merger produced a result so massive that it challenges even our revised understanding of black hole formation. The implications are profound. If black holes can undergo repeated mergers and produce ever more massive objects, then there is no theoretical limit to how large they can become. The universe can produce black holes of arbitrary size, but practical limits exist. The larger a black hole becomes, the less likely it is to undergo future mergers. The dense stellar clusters where these collisions occur are limited in number, in finite volume. The number of available merger partners is finite. Eventually, the largest black holes escape the clusters. They drift into the galactic field. They become isolated. They can no longer merge. But before reaching that point, they can grow to enormous sizes, to masses measured in hundreds of solar masses, possibly more. The universe is not building these monsters by accident. The universe is building them systematically. Mergers after merger after merger. A slow accumulation of cosmic violence producing objects of staggering scale. Globular clusters are cosmic cities, spheres of stars, millions of them, packed into volumes where stars orbit so close to each other that gravitational interactions are constant. A star ventures near another star. The gravitational pull alters its trajectory. It is deflected. It moves to a new orbit. Another star approaches. Another deflection. The stars are in perpetual motion. A cosmic dance performed by millions of partners simultaneously. And at the centers of these clusters, something darker occurs. The black holes gather. They sink to the center through gravitational interactions. They cluster together. The density of black holes at the cluster core is incomprehensible. Thousands of stellar mass black holes in a volume smaller than a light year across. They orbit, they interact, they collide. Consider the dynamics. A black hole approaches another black hole. Gravitational attraction pulls them together. They enter a binary orbit. They circle each other. But the cluster is crowded. A third black hole approaches. It passes nearby. Its gravity affects the binary. The third object can eject one member of the binary to high velocity. The other remains. The process repeats constantly. Some binaries merge. Others are disrupted. New binaries form. The environment is violent, chaotic, unpredictable. But statistically, mergers occur regularly, very regularly. A black hole in the center of a globular cluster can undergo multiple mergers in a few 100 million years. This is remarkably rapid on cosmic timescales. The formation of massive black holes is accelerated by the dense environment. The nuclear star clusters at the centers of galaxies are even more extreme. These are regions within a few light years of a supermassive black hole. Stellar density is astronomical. Hundreds of thousands of stars compressed into tiny volumes. Black holes cluster around the supermassive monster. They orbit, they interact, they merge. The merger rate in nuclear clusters is orders of magnitude higher than in globular clusters. A stellar mass black hole entering a nuclear cluster might undergo dozens of mergers before escaping or being consumed by the supermassive black hole. The accumulation of mass is rapid. The evolution is violent. And the result is a population of increasingly massive black holes. Second-generation objects born from mergers. Third-generation objects born from mergers of merged products. The hierarchy builds. The tidal environment in these clusters ensures constant mergers. When two binaries interact, the tidal forces can cause exchanges. A three-body system becomes two separate binaries in different configurations. One binary might be tighter, the other looser. The tight binary loses energy to gravitational waves. It merges. The loose binary remains. New configurations, new binaries, new merger opportunities. The mathematical chaos of three-body dynamics ensures that every possible configuration is sampled. Eventually, most binaries merge. This is not speculation. N-body simulations of cluster dynamics confirm this behavior. Computers model millions of gravitational interactions. The simulations show that mergers are inevitable. Mergers are frequent. Mergers are the natural consequence of crowded dynamics. The radiation environment in these clusters is intense. X-rays flood the region. Accretion disks around black holes emit radiation constantly. Stellar collisions produce shock waves. Radiation heats the gas. The gas becomes ionized plasma. The environment is hostile, dangerous, destructive, but it is also the environment where massive black holes are born. Violence breeds violence. Merger begets merger. The process is self-perpetuating. The more mergers occur, the more massive black holes exist. The more massive black holes exist, the higher the collision rates. The higher the collision rates, the more mergers occur. It is a positive feedback loop, a system that self-amplifies. The universe is building monsters through systematic escalation. The escape velocity from these clusters is high. Objects formed in the cluster have difficulty escaping to the galactic field. They are trapped. They remain. They interact. They merge repeatedly. A black hole that forms in such an environment is destined for multiple mergers. It cannot escape until it has grown massive enough to overcome the cluster gravitational potential. But gaining that mass requires mergers. It requires exposure to the dense environment. The black hole cannot escape the violence. It must participate. It must collide. It must merge. The cycle is inescapable. This is the cosmic tragedy. Objects born in these environments are sentenced to collide with their peers repeatedly until they grow massive enough to escape. And by the time they escape, they have undergone numerous transformations. They are no longer what they were born as. They are products of accumulated violence, survivors of cosmic warfare. And these survivors drift through the galaxy carrying with them the scars of their history. The recent detections reveal that these processes are more common than we believed. The universe is producing massive black holes through mergers at higher rates than predicted. The galaxies are filled with products of repeated collisions. The cosmos is not a calm place. It is a tournament, a competition between black holes for dominance through merger. Winners and losers, survivors and vanquished. And the survivors continue to grow. They continue to accumulate mass. They become larger, more massive, more powerful, until finally, something truly cataclysmic occurs. What happens when one of these second-generation monsters encounters another like itself? The moment of merger arrives. Two black holes, masses approaching each other at relativistic speeds. The separation shrinks to nothing. The event horizons touch. The merger is inevitable, irreversible, final. And in this moment, something profound occurs. Something that defies intuition. Something that breaks our everyday understanding of reality. Space-time itself reaches its limit. The curvature becomes infinite at specific points. The mathematics predicts singularities, regions where the equations produce infinity, where physics breaks down, where our understanding collapses. Imagine the space-time geometry surrounding the black holes just before merger. It is warped, twisted, distorted beyond recognition. The curvature is extreme. Near each event horizon, space-time bends so severely that parallel lines diverge. The geometry is non-Euclidean. The rules of flat space do not apply. Add another black hole. The distortion doubles. The warping intensifies. The curvature increases exponentially. As the black holes approach, the regions of extreme curvature merge. The geometry becomes increasingly complex, more twisted, more extreme, stranger, and then they touch. What happens at the moment of contact? The event horizons merge. Two separate boundaries between the interior and exterior of spacetime become one single boundary. The topology changes. The geometry transforms. The mathematics demands a new configuration, a new equilibrium. The system cannot remain in the previous state. It must transition to something different, something new. And the transition is violent, catastrophic. The space-time oscillates. It rings like a bell struck by a hammer. The oscillations are gravitational waves, the vibrations of reality itself. The entire region ripples with disturbance. Waves propagate outward at light speed, carrying energy, carrying information, carrying the news of the collision across the cosmos. The spin configuration becomes critical at merger. If the black holes spin in the same direction, the merger is relatively calm. If they spin in opposite directions, the merger is violent, chaotic. The angular momentum vectors are misaligned. The result is a black hole that is spinning rapidly but off-axis. It wobbles. It precesses. The jet emission becomes asymmetric. The gravitational waves are beamed in specific directions. The recoil is extreme. The newly formed black hole can be kicked backward by the asymmetric gravitational wave emission. It can be ejected from its original location, launched into space like a cosmic cannonball. Recent detections show exactly this behavior. Black holes spinning perpendicular to each other, mergers producing extreme recoils. The universe is violent in ways we did not anticipate. The temperature at the moment of merger reaches values that approach the Planck temperature. The Planck temperature is the scale at which quantum gravitational effects become dominant. It is approximately 10 to the power of 32 Kelvin, the highest temperature that exists in the observable universe. The early moments of the Big Bang approach this temperature, and for the briefest instant during black hole merger, similar conditions arise, not everywhere, but in the immediate vicinity of the merging horizons. The physics in this region is quantum gravity, not classical general relativity, not quantum field theory, but a yet unknown theory that combines both. We do not know what happens at Planck scales. The theories we have developed are insufficient. The universe is showing us physics we do not understand. The newly formed black hole is not in equilibrium. It is excited. Its spacetime is oscillating. It is ringing. This ringing is called the ringdown. The black hole emits gravitational waves as it settles into its final state. The frequency of these waves is characteristic of the black hole mass. The decay rate is characteristic of the spin. By analyzing the ringdown, scientists can test whether the final object is truly a black hole. Whether general relativity predicts the correct spectrum of oscillation modes, the tests have been performed. General relativity passes. The ringdown frequencies match predictions, but the precision is limited. Future detectors will make these tests more precise. They will probe the black hole ringdown in unprecedented detail. They will look for deviations from general relativity. They will search for hints of physics beyond Einstein. So far, Einstein wins, but the universe might be hiding surprises. The accretion disks surrounding the black holes have interesting fates. They do not merge smoothly with the black holes. They have momentum. They have energy. When the black holes merge, the accretion disk dynamics become chaotic. The disk can become unstable. It can eject material outward at high velocity. It can produce jets. It can emit intense radiation. The electromagnetic signatures of a black hole merger are often more visible than the gravitational wave signals. Telescopes observing the system detect sudden changes in brightness, sudden changes in X-ray flux, sudden changes in radio emission. These electromagnetic signals complement the gravitational wave data. They provide additional constraints. They confirm that a merger has occurred. They provide independent evidence of the event. The merger is complete. The two have become one. The spacetime around the new black hole settles. The ringdown decays. The radiation output decreases. The electromagnetic signals fade. The system enters a new equilibrium. A new black hole exists where two previously existed, more massive than either predecessor, more energetic, more extreme. But now comes a question that redefines everything. This new black hole carries the accumulated history of mergers. It is not alone in the cosmos. Other black holes exist nearby, other monsters. And as the new merged black hole drifts through the galaxy, it might encounter yet another black hole. The energy released during merger is incomprehensible. Truly, not exaggeration, not hyperbole, incomprehensible. During the final seconds before two black holes merge, they accelerate to speeds approaching that of light. They orbit at velocities exceeding 50% light speed. The kinetic energy is astronomical. The gravitational binding energy is astronomical. And in the moment of merger, a fraction of this energy is converted to gravitational waves, to radiation, to the vibrations of spacetime itself. The numbers defy intuition. Consider the GW23103 event. Two black holes, 110 solar masses, 115 solar masses, combined mass, 225 solar masses. The result, approximately 201 solar masses. Where did the rest go? 24 solar masses of pure energy, converted to gravitational waves. Einstein's equation, E equals mc squared, 24 times the mass of our Sun times the speed of light squared. That is the energy radiated. How much is that? Compare it to the total power output of all stars in the observable universe. There are perhaps 1 septillion stars. Each produces a certain amount of power. The Sun produces approximately 4 times 10 to the 26 watts. All stars combined produce approximately 10 to the 50 watts. The energy released in the GW23123 merger happened in fractions of a second. The power output during those fractions of a second exceeded the combined power of all stars in the observable universe by orders of magnitude. This is not abstract calculation. This is physical reality. The gravitational wave detectors measured the energy. The signal amplitude encoded the power. Scientists perform calculations. The numbers are real. The energy is staggering. For a single second, the merger outshines the entire cosmos, the entire observable universe, all 100 billion galaxies, all 100 septillion stars. The merger is brighter, more energetic, more violent than everything else combined. And this violence is not visible to ordinary telescopes. No photons, no light, just gravitational waves, just space-time ripples, just the vibrations of reality itself. The energy density in the merger region is extreme, joules per cubic meter. The density reaches values comparable to the core of a supernova, comparable to the interior of a neutron star, comparable to the conditions 1 microsecond after the Big Bang. The universe is recreating its own history, in miniature, in localized regions. The merger is a laboratory, a cosmic experiment showing what physics looks like in extreme regimes. The fields are quantum. The gravity is classical relativistic. The interaction between quantum fields and classical geometry is profound, unknown. The physics that operates in the merger region is not fully understood. It is at the frontier of human knowledge. The gravitational wave power output is equally extreme. Gravitational waves carry energy. Photons carry energy. Both follow similar principles. The power in gravitational waves is measured in watts, petawatts, exawatts, zetawatts, the largest unit we commonly use. A zettawatt is 10 to the 21 watts. The merger produces multiple zetawatts of gravitational wave power for fractions of a second, all radiating outward at light speed. The energy spreads across the expanding sphere of gravitational waves. The amplitude decreases with distance, but the total energy remains conserved. By the time the waves reach Earth, after traveling for billions of light years, the amplitude is tiny, but measurable, detectable. The LIGO detector captures these faint ripples. It reconstructs the original energy. It reveals the violence billions of light years away and billions of years in the past. The energy released could power human civilization for eons. The total world energy consumption is approximately 600 exajoules per year. The GW2311123 merger released approximately 10 to the 47 joules, enough to power human civilization for 10 to the 35 years. 35 billion years, far longer than the age of the universe. The comparison is meaningless. The numbers are so vast that human intuition fails. We cannot grasp them. We can only calculate them, only observe them, only measure them. The universe casually releases more energy in a merger than humanity could use if we continued at current consumption rates for trillions of times the current age of the universe. This energy comes from somewhere. It is not created. It is not generated. It is released from the gravitational binding energy of the system. The two black holes possessed enormous gravitational potential energy by virtue of their separation. As they merged, this potential energy converted to kinetic energy. The kinetic energy of the infalling material was converted to heat, to radiation, to gravitational waves, to the vibrations of spacetime. The energy was always there, locked in the system. The merger just released it, transformed it, made it manifest. And in that manifestation, the universe revealed its secrets. The universe showed us what happens when gravity reaches its extreme, when spacetime is pushed to its limits, when physics itself enters uncharted territory. The energy release is merely the symptom. The real revelation is about what the universe can do, what it is capable of, what extremes it can achieve. The merger is complete. The two have become one. But the new black hole is not in equilibrium. It is wounded, traumatized, vibrating. The space-time surrounding it oscillates. The geometry rings like a struck bell. This is the ringdown, the final cry of the merger event. The last gravitational waves emitted before the system settles into silence. And these waves are peculiar, distinctive. They encode the properties of the newly formed black hole. A normal black hole at rest emits no radiation. It is stable, peaceful. It can sit for trillions of years without change. But a black hole born from merger is not at rest. It is spinning rapidly. It is wobbling. The event horizon is distorted. The geometry is not perfectly spherical. It is lumpy, irregular. Over time, the ringdown smooths these irregularities. The geometry settles, the spacetime relaxes, and during this relaxation, gravitational waves pour out. Specific frequencies, specific amplitudes, specific patterns, the signature of a black hole settling. The ringdown frequencies are determined by the black hole mass and spin. These are fundamental properties, immutable, unchangeable. The frequency is not arbitrary. It is predicted by general relativity. Einstein's equations determine exactly what frequencies will be emitted. By analyzing the ringdown, scientists can measure the final black hole properties. They can extract the mass. They can extract the spin. They can confirm that the merger produced exactly what relativity predicted. Or they can find deviations. They can find hints of physics beyond Einstein. So far, every ringdown observed has matched predictions perfectly. General relativity remains undefeated. The ringdown decay rate is equally predictive. The amplitude of oscillations decreases over time. The decay follows an exponential pattern. The decay timescale depends on the black hole properties. It depends on the mass. It depends on the spin. It depends on the specific oscillation mode being excited. By measuring the decay, scientists extract additional information. They refine their measurements. They increase their precision. The ringdown is a treasure trove of information about black hole physics. Recent detections have pushed the analysis to unprecedented precision. The LIGO detectors have registered multiple oscillation modes simultaneously, multiple frequencies emitted at the same time. Each mode decays at its own rate. Each mode carries distinct information. The combination of all modes provides an overdetermined system. Scientists have more data than equations. They can check for internal consistency. They can test whether the data truly represents a black hole or something else. The tests pass. Black holes behave as predicted. Reality matches theory. But the ringdown also reveals something subtle. The quality factor. The decay rate of oscillations. This factor is related to the entropy of the black hole, the information content. Black holes are thermodynamic objects. They have temperature. They have entropy. They emit radiation through Hawking emission. The ringdown decay is connected to these quantum properties. By measuring the ringdown precisely, scientists are indirectly probing the quantum nature of black holes, the connection between classical gravity and quantum mechanics, the frontier of physics, the boundary of understanding. The ringdown signals from recent mergers have surprised scientists. Some ringdowns decay faster than predicted. Some show unexpected features. Some reveal asymmetries in the oscillation modes. The interpretation is challenging. The physics is not yet fully understood. Is this a sign of physics beyond general relativity? Or is it simply noise or measurement artifact? The scientific community debates. More observations are needed. Better detectors are required. Future gravitational wave observatories will measure ringdowns with unprecedented accuracy. They will either confirm Einstein's predictions even more precisely, or they will find the cracks in the foundation. They will find hints of quantum gravity. They will find evidence of physics yet unknown. The ringdown eventually fades. The oscillations decay to imperceptible levels. The space-time around the new black hole becomes smooth, regular, peaceful. The geometry is now that of a Kerr black hole, a spinning black hole in equilibrium. The merger is truly complete. The event has concluded. The gravitational waves have ceased. Silence returns. But the damage is done. The space-time of the region has been permanently altered. The merger has left its mark. The new black hole carries the mass, the spin, the memory of the merger. It carries the accumulated history of all previous mergers that created its precursor objects. And now, this new monster will drift through the galaxy. It will interact with other objects. It will move through stellar clusters. And eventually, it might encounter yet another black hole. It might merge again. It might become even more massive. But before we contemplate that future, we must ask ourselves a different question. A question about meaning, about purpose, about what it means for us to understand these cosmic events at all. We exist. This is fact. We are here, on a small planet orbiting an ordinary star in an unremarkable galaxy among hundreds of billions of galaxies. We are composed of atoms, carbon, oxygen, nitrogen, hydrogen, forged in the cores of stars. These atoms are ancient. They have existed for billions of years. They are older than Earth, older than our solar system, older than humanity. These atoms were processed through stellar furnaces. They were ejected when stars died. They were incorporated into nebulae. They were assembled into planets. They became the matter of life. They became us. But there is more to our history than stellar alchemy. The galaxies that contain the stars that created these atoms are shaped by gravity, by the cores of black holes, by supermassive monsters sitting at the centers of galaxies. These black holes determine galaxy structure. They determine how galaxies form, how they evolve, how they merge. The black hole at the center of our galaxy, Sagittarius A, is a supermassive monster of 4 million solar masses. It is a prisoner of our galaxy, chained to the core. And yet its influence extends throughout the Milky Way. Its gravity shapes the orbits of stars. It shapes the density distribution. It shapes the very structure that makes our galaxy possible. Without the supermassive black hole, the Milky Way would not exist. we would not exist. Our existence is intimately connected to the black hole at our galaxy's center. And that black hole has a history. It grew. It consumed material. It merged with other black holes from smaller galaxies that collided with the Milky Way. Billions of years ago, the Milky Way encountered Andromeda. Not yet. That collision will occur in a few billion years. But the Milky Way has collided with other galaxies. It has merged with companions. Each merger brought a black hole. Each merger resulted in a collision of supermassive black holes. The merger we study now, the event of two supermassive black holes colliding, is not hypothetical for us. It is our future. In approximately 4 billion years, Andromeda will collide with the Milky Way. The supermassive black holes will approach each other. They will merge. Our galaxy will transform. The merger is inevitable. The timeline is certain. We might not be here to witness it. Humanity is unlikely to survive 4 billion years. Extinction events are frequent. Our species is fragile, but the merger will occur regardless of our presence. We are studying the future of our galaxy. We are observing in distant sources what will eventually happen to us. The gravitational waves detected by LIGO are messages from the cosmos. They are telling us our story. They are showing us what awaits our galactic home. They are revealing that we live in a universe of violence, of mergers, of transformation. The universe is not static. Galaxies collide. Black holes merge. Stars are ejected. The cosmic landscape is constantly changing. It is dynamic. It is violent. It is beautiful in its cruelty. And we have the capability to perceive this. We have built machines so sensitive that they can feel the ripples of spacetime from events billions of light years away. We have developed mathematics that can predict these events billions of years in advance. We have achieved something extraordinary. We have developed the capacity to understand our place in this cosmos, to comprehend the forces that shaped us, to recognize our connection to the extreme physics operating in the depths of space. We are not separate from this universe. We are part of it. We are made of its matter. We are subject to its laws. We are products of its history. The black hole mergers are not abstract phenomena. They are connected to us. They are connected to every atom in our bodies. The carbon in our cells came from stars. The oxygen came from stars. The nitrogen came from stars. All of it was processed through the deaths of massive stars. All of it was incorporated into our galaxy through the chaos of galactic evolution. And galactic evolution is driven by mergers, by black holes, by gravity, by the same forces we study now. We are literally made of the debris of cosmic violence. We are the products of mergers. We are the offspring of catastrophe. And yet we are conscious. We are aware. We can understand. We can comprehend the cosmos that created us. This is the revelation that transcends physics. We are the universe experiencing itself. We are the cosmos looking back at itself. We are the universe asking questions about its own nature. Through our observations, through our mathematics, through our instruments, we are not separate from the events we study. We are continuations of them. We are the end result of billions of years of cosmic evolution, of mergers, of collisions, of transformations. When we observe a distant black hole merger, we are observing our own past. We are observing the forces that created us, and we are preparing ourselves for our own future. When our galaxy merges with Andromeda, when our supermassive black hole collides with another, we will become part of a new cosmic drama, a new merger, a new transformation. This is not end. This is continuation. This is the eternal dance of matter and gravity and space-time. We are dancers in this cosmic ballet. And the revelation is that we are conscious of the dance. We understand it. We study it. We predict it. We are the universe finally becoming aware of itself. That is what it means to exist in this cosmos. That is what it means to be human. We are the universe trying to understand itself. And in that understanding, we have found not despair, but wonder. Not fear, but awe. Not isolation, but profound connection. We are part of something vast beyond measure, something ancient beyond comprehension, something beautiful beyond expression. And that, ultimately, is what the merger reveals.